Section 2.10 covers negating statements. So what is a negation? So if I've given a statement P of X, then the negation of that we have seen is just the statement that's written, not P of X. So it's going to be a statement which is true when P of X is false, and false when P of X is true. So it's a statement that has the exact opposite truth value. And I find it's helpful to remember, right, that in our world, in our universe, there's two options. Either P of X is true, or not P of X is true. But those are the only two options. I can't have neither be true. I can't have both be true. So my Venn diagram for this would be two circles that didn't overlap at all and that took up the whole universe. So if I'm thinking maybe more closely related to the language we're using, if we consider sort of our universe or a universal set, for all x, either P of X is true or the negation of P of X is true. So they're exactly opposite of each other in terms of those truth values. So let's imagine the following scenario, and we're going to think about this in terms of negation. So, all right, you're trying to sit down back in the time when everyone's together, and we're ordering pizza. And so somebody says, does everyone like either cheese or pepperoni pizza? Right, so the statement we're really thinking about here is everyone likes either cheese or pepperoni. And we're trying to decide whether or not that's true, because if it is true, we can order a cheese pizza and a pepperoni pizza and be good. But if it's not true, then we're sort of stuck. So we get feedback from three friends here. So Allie says, I like both. Okay, well, if she likes both, then remember the or, it's always that inclusive or. So that works. She's going to be happy if we get both cheese and pepperoni pizza. Ben says, I don't eat meat. Right, so he's not going to want that pepperoni pizza, but presumably he will eat that cheese pizza. So that's good. The statement is still true. But then Charlie says, I only eat pizza with pineapples on it. So for him, he's not going to like the cheese or the pepperoni because neither of those have pineapples. So this is sort of an example of someone who's going to be in that negation category, right? So here the negation is true. And what made the negation true, right? It wasn't that he just didn't like pepperoni or that he liked both. He didn't like the first and didn't like the second, right? So he didn't like cheese because that doesn't have pineapples. And he didn't like pepperoni. So oops, I spelled that wrong. Let's fix that. What we can see here, right, when I negate this or, we have this or here that we're negating. That or became an and. In order to not like either, you can't like the first and you can't like the second. So that's one thing I wanted to point out. The other thing I want to point out, and we'll talk about this a bit more, right, to say no, to find out that this statement was false, that everyone liked either cheese or pepperoni, we just found one person who didn't. So in order for that one person to not like either of them, that's going to negate that everyone. So up here I have a for all, and in my negation, I end up with a there exist. So these are the sorts of things that we want to look at in this section. Right, so we'll see that an or does become an and when we negate. A for all does become a there exists when we negate. Right, and that kind of makes sense with this example. Let's look at one more of these examples, and then we'll get into the more formal stuff. All right, let's look at this next statement here. It says, all dogs wear capes and goggles. And, for example, we have 3 dogs. It is true that of all of the dogs I currently have on this screen, they all have on capes and goggles. I just did a random Google image search for dogs with capes and goggles, and they all somehow have red capes. I thought that was funny. Right, but that seems like it's true so far. But if anyone can give an example to show that that's false, then we'll know. So what would example look like if you're like, no, it's not true that all dogs wear capes and goggles? So let's see, I've got some images stored here. I could give you this dog. This dog has a cape, but no goggles. So that's already proving the statement wrong, that all dogs have capes and goggles. Because here's a dog that has no goggles. Oops, did I spell it? I said googles instead of goggles. I said that Google's up there as well. Let's fix that. Goggles. So there's a dog that has no goggles. Let's see what else we have ready for us. Here's a dog that has goggles, but no cape. He has a scarf on, but that's not a cape. We'll label that as a scarf. Be very specific here. So he has no cape. Right? So as long as you have at least one of them that you don't satisfy, you're not going to satisfy the and. I could also show a dog. Got one more ready to go here. That has no cape or goggles. He's kind of sad because he doesn't have a cape or goggles. And that would also show me that my statement is wrong. So what are we actually doing to show that this statement is wrong? Right? If it's not true that all dogs wear capes and goggles, then there is at least one dog. So we had 3 different examples, but any of these could prove my statement wrong, who either doesn't have goggles, man, goggles is really hard to spell, or doesn't have a cape. And again, right, we're using our math or here, so that automatically includes or both. So it both doesn't have a cape or and doesn't have goggles. Right, so again, let's think about what we're doing here. We have a for all quantifier, and when I negated that, that became a there exists. And I have an and when I negated that, oops, I drew the or symbol. When I negated that, it became an or. So again, these are the things that we want to think about in this negation section. So we'll start with a discussion of our ands and ors. We've actually seen this before. These are De Morgan's laws, and we looked at them in terms of truth tables. So if I want to negate a P or Q, right? So I'm going to say it's not true that either P or Q are true. The only way either P or Q can't be true is if they're both not true. Because as long as at least one is true, then the or is true. So the negation of this is not P and not Q. So they're both not true. So when I'm negating an or, I can kind of think about distributing this negation to each guy. So the P got negated. The negation of an or is an and. That's not really a real statement that I can say, but it's helpful to think about when I'm symbolically negating. So I distribute this negation, that or becomes an and then that Q becomes a not Q. All right, moving down. If I want to negate an and here, so it's not the case that P and Q are true. Well, if they're not both true together, then either one of them is false or the other one is false, right? Or again, or both are false. But this or in math always includes that or both case for us. So the negation of an and is always that or. And again, you can kind of think about distributing that negation, and the negation of that and becomes an or. Again, I'm going to say one more time, this isn't like a real thing. I'm not really distributing. It's just a helpful thing to keep in our mind as we're doing these to help us with the symbolic negation. All right, so let's actually try these. I've got two statements here. Both x and y are odd. All right, so I can write this as x is odd and y is odd. Now, if I want to negate that, my negation should be it's not the case that x is odd, or it's not the case that y is odd, or both. Assuming x and y are integers, then if they're not odd, that means they're even. So I could say x is even. Let's use logical equivalence here. Or y is even. So if it's not the case that they're both odd, then one is even or the other is even, right? Or again, or both. But we have that implied or both. So if I want to write that in words, I could say either x or y are even. I feel like when I have either, it seems like it's going to have an implied exclusive or, so I'm just going to say x or y are even. Maybe we'll say either. That seemed weird. X or y are even, and I'll put in parentheses, or both, just so it's clear. Because in English, when we're using words, we usually mean an exclusive or, which doesn't include the or both category. All right. The integer x is divisible by 3 or 4. So then I would say x, this is the symbol for divisible, so we put it the other way. Well, I won't use the symbol. We'll save that. X is divisible by 3, right? So I would say 3 divides x if I wanted to use that symbol. Or x is divisible by 4. 4 divides x is my appropriate symbol there. So if it's not the case that x is divisible by 3 or x is divisible by 4, then either x is not divisible by 3, so 3 does not divide x, then I negate this, and x is not divisible by 4. So 4 does not divide x. So those are what that negation would be, right? If it's not the case that it's divisible by 3 or 4, then it's divisible by neither 3. It's not divisible by 3 and it's not divisible by 4. So then I could say x is not divisible by 3 and not divisible by 4. So it's divisible by neither 3 nor 4. It's kind of weird though, because then nor is actually playing the role of and when I say that. It's not playing the role of or. So that can be kind of confusing. As a final question for this little part, I want you to think about the following. So what is the negation of the statement not P and Q or R and not P? So I want you to take this entire statement here and negate that and figure out what that's going to look like in symbols. The rest of this section 2.10 is going to be covered in a part 2 video, just to kind of keep things a little bit shorter. So I encourage you, after you think about this discussion question, to go ahead and switch over to that part 2 video.